The flagship device that most people think of when they think of Layer 3 is the router. Routers have one mission, but it's a very important mission, and that mission is knowing the different paths to different networks. Let's take the previous image showing two different broadcast domains and let's add some details. This router has three active interfaces. One interface connects to the internet, another interface connects to the engineering subnetwork, and the third connects to the manufacturing subnetwork. As you can see, in the engineering subnetwork, all of the hosts have very similar IP addresses of 192.168.1.x, where x is a unique number, including the interface of the router that belongs to this broadcast domain. And the same happens with the second broadcast domain, where the manufacturing subnetwork is. The hosts here are using 192.168.2.x. In this example, the router connecting two different networks is also connected to the open internet. So if the computer with the IP address of 192.168.1.3 tries to connect to 192.168.2.3, the router receives the packets in one interface and then sends it out the other. But if the destination would have been something other than the subnet 192.168.2, the router would have instead sent the packet using the internet interface. This type of example is more common for corporate environments than home networks, since most home networks wouldn't have different subnets. Now, an exception to that is if you set up a guest network that is separate from your main network. Usually, those guest networks will live in their own subnets, although this can depend on the router, so it's something that you'd want to double check when configuring it. But splitting up a network into multiple subnets is done for several reasons. One common reason is that it's easier to manage. A second common reason is for performance. The larger the network, the greater the risk of running into network performance issues. And a third common reason is for security. For example, routers can be configured not to send packets between different subnets. So if one computer in manufacturing got infected by malware, it would be harder for it to spread into engineering. Let's take a closer look at how this works beyond just theory. When we learned about Layer 2, we looked at this router. This kind of router is mostly for home use, as we talked about. You connect your service provider into the internet port, and then you connect your devices to the other ports or even using Wi-Fi. In these routers, there is usually only one broadcast domain, meaning that all the devices connected have a common part in their IP address, which would look something like 192.168.1.2.1.3.4.5, and so on and so forth. Since all the connected devices are in the same subnetwork, this allows you to easily discover what's in your home. For example, you might want to discover a smart TV or a smart plug, and because it's in the same network, you're able to do that fairly easily. Now, just like we could check our MAC address in prior lessons, we can also check our IP configuration from the terminal or command line. Let's look at the IP configuration of our computers. Just like before, start the command line or terminal and write the command ipconfig. This is going to be my current IP configuration. As you can see, my IP is 192.168.0.5, but we also get additional information such as a network mask of 255.255.255.0, as well as a default gateway of 192.168.0.1. So what are those? How did my device get assigned that IP address in the first place? Those are all really important questions to answer, so let's complete this lesson, and in the next lesson, we'll start to answer them.